Let's go through the parameter tab. On the top, we can change the device name. At the moment, it's Sintrol demo device. Let's change this into Sintrol demo device S304. Now, what we notice is that the text has changed from black into red. That means that this information is not yet saved. So in order to keep that, I need to press save. Note, all information is saved straight to the device itself. It's not stored by DustTool. So even if you approach the device with another DustTool version or with another PC, all information will be read out straight from the instrument. Then averaging time. This equals parameter 2 on your local button interface of the S304. In your manual, you can read a description about all these parameters. There are also separate tutorials to each of these parameters which explains the functionality. If you have another device like a snifter or Dumo, some of these fields may not exist or be differently arranged. So let's change the averaging time from 50 seconds to, let's say, 1 second. 1. We save. Read out. It's 1 second. Now let's look at the monitor view, how the behavior of our instrument has changed. So from a very smooth output line, it's now much more nervous. I just touch now the probe, so I will probably, yep, you can see how it very fast reacts. Let's change that parameter 50, that parameter 2 back to 50 seconds. Save. Confirm that it has changed back. Let's have a look at the monitor view. So the output signal has clearly smoothened as the device is calculating the averaging time over the last 50 seconds. Let's go to the signal status. The signal status A and B represent your relays. If they are set as on a default on automatic, these relays will follow the relay logic as we have described them in your manual. If you want to change them, you can here force them to switch. For example, now if I change signal status of the first relay, this is normally energized. Now I want to relax it. If I press save, you can hear immediately the relay switching. Alright, and if we put it back to automatic, save again, and it switched again back. Then the milliamp output, this is more or less a diagnostic function. You can have it either automatically, so if I read now, changed from 4.33 to 4.23 milliamp. But you can also fix the milliamp output to any desired value between 4 and 20 milliamps. Let's say put here, save. Now your milliamp output would show straight 10 milliamps. The alarm delay time is set to be per default 30 seconds. Now that means that it will take 30 seconds until the relay is really switching after it has passed the programmed threshold. That prevents mainly false alarms, meaning, let's have a look here, the monitor view. I enforce the instrument to go up. You can hear that there is no switching on the relay at all, although it has passed that first alarm threshold. It needs to be uninterrupted for more than 30 seconds above this programmed threshold. Now, when I change the alarm delay time to be 1 second, the behavior will be different. Let's get up the reading of the instrument. A bit higher. You see? Switching, and it will immediately relax when it comes down. You hear it? Let's do that thing again. Bring it up. Switching. And then it comes down. And we'll switch again. This makes, of course, the reaction very fast, but especially in case of fabric filters which have a cleaning cycle, you may result into false alarms or too hasty alarms in case you have the cleaning cycle. Parameter 4 and 5 are representing the dust levels when the two relays are going to switch. In this case, relay A will switch at 1 million IEU and relay B at 4 million IEU. These are the default values how we deliver the instruments. If you would enable calibration to milligram per cubic meter, this would switch to milligram per cubic meter, and in this case it would switch 25 and 100 milligram per cubic meter. Let's double check that on our monitor device. It's now a milligram per cubic meter, and this is the alarm level. So if your dust level goes up and it stays there for more than 30 seconds, the alarm will switch. Flow compensation. Dust meters, based on the triboelectric principle, have a natural cross-sensitivity to the flow speed. Meaning, if the flow speed goes up, our reading will be a little bit higher, although the concentration actually stays the same. To compensate this effect, you can hook the milliamp output signal of a flow meter to our S304 or S305. Once you have done that, you can key in here what 4 milliamp and 20 milliamp of your flow meter actually mean. Usually 4 milliamp will be 0 meter per second and 20 milliamp will be, let's say, 10 meter per second. Don't forget to enable the flow compensation, save and read. From now on, our meter will show a completely stable dust concentration reading from 0 to 10 meter per second, regardless of the speed.